Hey, so the first part of this this unit, which was angles and triangles, which we just did. If you have a question about that, especially a proof question, do something with the angle, something to 180. That's one type of the proof. The rest of the unit is going to be a different type of thing we're looking at. All right. The rest, maybe not the rest, but I think, yeah, like most of the rest of this unit is trying to show two triangles are congruent. So if you look at the last section, it was, here's a triangle, you have to say the sum of the angles is 180. You will not do that moving forward. Okay, so moving forward, there's a different process. I actually think you're going to like it better. So first of all, two triangles are congruent. Well, we've talked about congruency of segments or angles. It means all their measures are equal. So for triangles, it means, actually, this is not for triangles. This is just for any shape. I shouldn't even say that this is triangles. Two quadrilaterals or anything that are congruent, exact same shape and exact same size. Similar figures have the different sizes. Now, here's more of a, this is more congruent figures in general. Here's the definition of congruent triangles. Two triangles are congruent if they have all three congruent sides. All of their corresponding parts are congruent. Three congruent sides, I'm sorry, three guys here. Three congruent sides and three congruent angles. There's 6 things in triangles that we need to know in order for the triangles to be congruent. 3 sides and 3 angles. If so, we say that the corresponding parts, those 6 parts, of congruent triangles are congruent. So the definition of congruent triangles is equivalent to saying CPCTC. That's an acronym we're going to use. It means the corresponding parts of congruent triangles are congruent. All the sides and angles. Yes, that is an acronym. I'm going to start putting these up. This is actually something I'm going to put up here. You will see that on the state test. Okay, this is they abbreviate it like this, CPCTC. So, you got a question about that? No. Yeah. Okay. So these are equivalent, guys. To say two triangles are congruent, you could say definition of congruent triangles, or CPCTC. They're equivalent. It means all 3 sides and angles are congruent. Okay, so now before we show, at the bottom we're going to show one set of triangles is congruent, example 3. Before we do that, something they want us to know is just how to name triangles, so like triangle ABC, sure. But they want you to know like the order of it, so that's more about example 2, but I have a drawing down here. I didn't exactly need a drawing for this one. All I want you to know is that, okay, from this is called a congruency statement. A congruency statement. All right, it just says that the triangles are congruent. I put it there that you need to make sure to match up the correct sides and angles. That's what I said right here. So, for example, I'll just do this one and say what I meant up here. I can conclude from this that the sides, like side AB, is congruent to side EF. Right? Like I wouldn't say AB is congruent to FG. They don't match up. All right, so that's what I want to mainly say from this. And there's 3 sides, and if you wanted to, you could draw a picture: A, B, C, E, F, G. Just make sure that you match it up. You draw A here, E here. You draw it in the same order. So what else? I can conclude, and again, you could draw a diagram or not. You could get this info. BC is congruent to FG, and AC is congruent to EG. Those are the 3 sides. Now, let me say something about this too. AB is congruent to FE, but that's not the best way to write it. They want you to go in the corresponding, meaning the correct order. Like A goes A to B, because A, this angle matches up with that angle, and E to F. So that's not the best way to write it. It would be eval. So this is all about just matching up the correct order of sides and angles. Okay, and then the three angles up there, so I could say angle A, congruent to angle E. By the way, you could name these angles with 3 points, like angle A is also called angle BAC. You could do that. But it's easiest if I can just to say a letter. So what? Angle A and E are congruent, angle B and F. And angle C and G. So let's just do, how about example 2, let's just do 2B below, and I think that will, and that will, I think, get the idea of what I'm saying here with the order. So let's do 2B. Write a congruent statement for these. They're saying they're congruent triangles. So you just have to, a congruent statement is saying triangle, you're naming the triangles and saying they're congruent. So this one, it doesn't matter where you start. So over here, let me start, let's do something different. How about I start with B? So I'll go BCA. It doesn't matter where I start on that one. What they want over here is you got to say the correct order over here. So for example, since I started with B, I wouldn't then start with C. Right? B doesn't correspond to C in the bottom triangle. So B does correspond based on the angle markings. It corresponds to D. And then, yeah, they both share C, so then I would say C. And then A corresponds to B. So that's all I want to say about matching. Any questions on example 1 or 2? It's about order and just making sure you match up the correct. A goes with E, that kind of thing. There are other ways to name this too. I could have said A, B, C, and what? E, D, C. And there's other stuff.
Wait, so if you would have said like triangle BCA is congruent to triangle DEC, that would be wrong.
Correct, because they didn't, like, you mixed these up, and you didn't correctly put them in order. Now, I don't know exactly how, like, it might be a multiple choice question on like the OST, and maybe the way you said it was the wrong answer, but this is the better answer. So you see what I'm saying? Like, it's best to match up the angles that go together. Mathematics is very technical. Like, you want to be very thorough, I should say, as well. Can I move on? Do one proof here? So this is an intro to, this is a type of proof we'll be, I meant to do a line, not a circle. Type of proof we'll be doing a lot moving forward. I in general will still do 2-column proofs, but we could do any type. Alright, so basically this. We have this given information, and with that we're going to prove the triangles are congruent. That's pretty much what we're going to be doing moving forward, is showing 2 triangles are congruent. Oh, I totally messed that up. Given goes there. Okay. Alright, so let me write out all this given and then we'll talk through this. AD and BE bisect each other. AB congruent to DE and angle A congruent to angle D. Okay, so really what we have to do here to show the triangles are congruent. 3 congruent sides. We gotta get that, and we gotta get 3 congruent angles. They've already given us and marked in the diagram 2 of those. And we'll actually quickly get the other 4. Alright, so they already gave us this, A, B, and D, E, they marked those sides, and they gave us these angles. Okay, so let me say this. The rest of this unit, you will not change these two equations. Okay, so you know how we've done that a lot in the past, change things to an equation, then we substitute stuff. Don't need to do that on triangle proofs moving forward. Because all you're trying to do is get three sides and angles congruent, and then you can say that done, the triangles are. You don't need to do equations. Okay, so let's, so this is done. Like, we're not going to do anything else that's given. We're not going to use it for anything else. So let's start here. Here's the other given. We haven't used that yet, so let's use that. AD and BE bisect each other. So AD bisects BE, so it cuts it in half. So can't I say those two are congruent? They cut in half. And at the same time, BE cut AD in half. So those two are congruent as well. Also, it's going to be good moving forward to mark your diagram. So do you see how I use 2 slash marks and 3 here? It tells they're different side lengths. These two are the same, but they're different from these two. All right, so I'm going to write BC is congruent to EC. B to C. So see, could I have said CE? Well, it's not the best answer. B to C and E to C match up. And then this is AC and BC. I didn't think about that until you laughed. That's a band. It's also an electrical current, right, or output of current.
I know AC
Let's see. So this was a vocab. This is not actually that new. This is vocab words. Right? Bisect. So we say the reason that that was congruent and that was congruent is because bisect. Definition of, and then you should put segment bisector. Alright, because there are angle bisectors and there are segment bisectors, so we need to differentiate which one. Alright, so do you see up here, if I'm checking this off, I have all three sides congruent that match up. So I'm good there. Now I need angles. Let's switch to blue. We had one, A and D, one pair given. Do you guys see, we don't have any other givens that can help us. Do you see another pair up there that are congruent? I would say there are, and I should say why. What type of angles up there do you see that are congruent? Anybody? Kenzie? There are alternate interior, very good. However, we don't have parallel lines. So we're gonna, you know what? Tomorrow we're gonna use that because we'll have parallel lines on some of them. Well, the lines we aren't given that they're parallel. So good. That's actually really good. There's another type of angle pair, easier than the 4 alternate interior.
Vertical.
Vertical, right here. I need to mark it with 2 arcs since there's already one. You can see those? They're intersecting lines. Vertical angles. We know vertical angles are congruent. So I'm just going to say those two. Please don't say C and C. You can't name them C and C because we don't know what angle C is.
C1 and C2.
No. So let's say ACB. So that was the left triangle. I did A to C to B. And the right triangle, it would then therefore be DCE.
Should it be ECB because it corresponds to something?
Good question. Well, I started with A, and since A had one arc marked, it matches up with D. So I need to put those together.
Oh, this is so confusing.
No, it's just technical. You gotta, okay, A matched up with D. And then C and C matched up, certainly. And then B to E. Vertical angles theorem. Did I write? Oh, what am I got a little off there. Okay. Step 3, sorry. Vertical angles theorem. Or just say any two vertical angles are congruent.
So would it be wrong if I said like ECD instead? Would that be wrong?
Well, you could say ECD and then For the other angle, you'd have to say BCA.
But then what if I accidentally do it? Are you gonna like take points off of that?
Yeah. Well,
Oh.
I have to prepare you for what they're asking, so. But you see how this matches up better.
Okay, well I thought that it matched it better the other way because A and E both are.
Oh, well here, this triangle is flipped of this one. That's what they did. So they said, well, A must go with D because of the markings. Yeah, good
I
question.
thought that you could just name angles however you wanted.
By the way, I've marked my diagram so that then you can see, all right, when do we have all three sides? When do we have all three angles? All right, so guys, last one here is we need angle B and E congruent. Well, I have two angles here congruent to two angles there.
Oh, this is the one.
So is there a reason why the third angles
Yeah, it's that theorem.
would, it's that one theorem.
Yeah,
Isn't that beautiful? Well done. So angle B, and yes, I can say B because there's no confusion about what B is. Angle B is congruent to angle B. Third angle theorem.
It's just such the curve ACB is congruent to DC.
The triangles? Yeah, we got one more step.
Oh, I thought it was an angle. No, never mind.
So what we just showed is yes, two angles are congruent, therefore the third angles are. Third angle theorem. We have all three angles now. We had all three sides. Now you can say that the triangles are congruent. So I just put triangle ACB congruent to triangle DCB. And this is what I said at the top. You can write definition of congruent triangles, or you can write CPCTC. It's up to you. I'll put both here, just so you know. Congruent triangles. Or you could have put CPCTC. Because this means all six sides and angles are congruent. That's what CPC is. It means corresponding parts, the sides and angles of congruent triangles are congruent. So again, big difference here, you're not changing any of these two equations. Alright, you're just going to say, hey, I need to get three congruent sides, three congruent angles. That's the goal. Okay, anything else I can answer on this one? By the way, Kenzie, I was thinking about it. The other thing is they give you the order of these up here. So like, if I'm trying to match it up and I did ACB, which is that, then I should do DCE.
Well, yeah, but.
And that's what it ended up being over here. So I just
Well,
matched
in
them
the
up.
middle of the equation, you don't always end up.
I think what this right triangle is the flip version of this one. So, well, last thing I want to say before I'll let you work on just page 4 of the practice is these type of triangles. They look like a bow tie, right? So you'll hear me say, hey, if there's bow tie triangles, you will always do vertical angles. Got it. So if you see bow tie triangles in the future, vertical angles. Say they're congruent. That's at least one thing you'll know for sure. Also, don't introduce new things if it's not given. Besides, you could do vertical angles, but if it's not given up here, you can't just say, oh, midpoint, or oh, alternate interior. We didn't have parallel lines. Okay, sounds good. I'll let you guys work on